got 5 minutes to lunch. I don't even have our presenters. Start. Well, we don't have Daniel, Daniel's the best presenter. Oh.
So we're going to give it a couple more minutes because people are still having lunch and we're missing some of our presenters still.
We don't have a lot on the agenda. So 5. Find him. Yeah, start. John, let's start. Well, let's start if we're just waiting.
Okay, so welcome to NVO3 in the last slot of this IETF. I'm Matthew Bocci, and my co-chair Sam Audrey, and we're usually doing the minutes today. Our secretary, thank you. Here is a note. Well, I'm sure you've seen this many times this week, but we have to show it once again. Basically, it says that anything you say here is a contribution to the IETF. Okay, blue sheets are going around. There's one on each side of the room. Please sign the blue sheets, and if you're the last person at the back of the room with the blue sheet, if you could bring it to the front when you're done, that'd be much appreciated. So the agenda, we have 4 drafts on the agenda, in addition to the this working group status update. Any comments on the agenda? Okie doke. So milestones. So as usual, these are completely out of date, and we need to update them. These are the ones from the data tracker. I've just quickly updated the milestone regarding the data plane solution, which is Geneve, which has been submitted to the IESG, well, to Martin now. But we need to come up with some sensible timelines for the rest of the milestones. So watch this space. Any comments on the milestones? Apart from they're out of date. Okay. Document status. So we have quite a few RFCs, but no new ones since the last IETF. Our most recent one was RFC 8394, the split NVE document, control plane requirements. So an update on the data plane encapsulation. So Geneve, draft Geneve, which was the data plane encapsulation identified by our data plane encapsulation design team, is now with Martin. So we've requested publication for that. We have another draft which describes the output of the data plane encapsulation design team, which I think at the time we thought was useful to publish. Sammy?
Yeah, Sammy Boutros. Yeah, I don't think we are going to update it more. So it should be ready for last quarter.
Okay.
Thank you.
Okay. Can I just get a show of hands of who recently has read the data plane encapsulation draft? Okay. It's a reasonable proportion of the number of people in the room. So. Okay, so we'll probably take that to the list and do a poll, because that's a pretty mature document. It was just the output of the design team, so we decided it was a good idea to at the time to publish that really as a documentation of our experience in picking an encapsulation from multiple competing encapsulations. Martin, do you want to say something?
Martin as routing AD. I'm fine if the working group believes that it's needed. Be aware that typically on some of these types of documents, IESG tends to ask whether that's really needed to publish as an RFC.
Yeah, this is more for the benefit of the broader IETF to document the process by which we picked an encapsulation format when we had quite a lot of controversy around which encapsulation should move forward, and this is something that happens repeatedly in different working groups. So it's really
okay. Is that clear early in the document that that's the type of information we'll find?
Yeah.
Okay.
Should be. Okay. In working group last call, so we had the EVN applicability to draft Geneve, which is currently with the document Shepherd. So that went through working group last call. There wasn't any objection to that. I think Samuel, you're handling that. Do you want to give an update on where you are?
So I think the Shepherd write-up is overdue, so I will be doing that after the IETF meeting.
Right. We also had a virtual machine mobility draft that some of you may remember. that went through working group last call last year, it also had some reviews and quite a lot of discussion on the list from TSV area review team, the ops directorate, and there was also a routine directorate review. And I think that some of the issues that were raised by the TSVR and ops directorate reviews weren't fully addressed by the editor at the time. And the editor has since gone absent. So we have a volunteer to pick up the pen on the draft, which was Linda. Why has that gone? Apologies, it looks like we have a technical problem. There we go. Yeah. Not quite sure what happened there. So hopefully we'll be able to move forward with that document and get those reviews addressed. I don't think there was any other real problems with that were raised during the last call. I think it was mostly some comments that were raised during these area reviews that needed to be addressed properly. So thanks, Linda, who's unfortunately not here, for picking that up. There's actually a bad connection in this cable.
Tom Mizrahi, just a short question regarding the VXLAN GPE document. Do we have a plan to publish that in the future? So
now that Genève has been published, well, not been published yet, but now Genève is with the ISG. So I think just to refresh the working group's memory, the original decision was that the other encapsulation drafts could go forward as informational or experimental following the publication of Genève. So that's really, yeah, I mean, it's kind of up to the authors to at least refresh the drafts. And so can I get a show of hands maybe who has read any of those other encapsulation drafts, such as VXLAN GPE recently? Okay, a few. I think it would be, I mean, we did promise we would do that, and a working group agreed to do that. So I think we should probably, maybe after the design team encapsulation draft has been published, has gone to the ISG, it'll be good time to then.
Okay, thanks.
Then publish those, because then there's a little bit of context to the ISG about why we're going forward and publishing these other encap drafts.
Okay, Greg Mirsky, ZT. I appreciate it. Tal brought it up. So you mentioned that because GUI went to a different area for its own path. So VXLAN GPE, you consider it to be informational or experimental?
Yes.
Okay.
Yeah, because this working group decided to pick one standards track.
Okay. How much of influence you see that the working group will have over the informational experimental track document?
Well, they're still working group documents here. They're not individual submissions to the RFC editor. That's not the track. It's not like when we originally did VXLAN and that went to individual, in which case we didn't own it. This we own because it's a working group document.
Because in my interpretation of experimental and informational, it's just reflective whatever been implemented. So it's not that.
I think that's true for experimental, but for informational, it's definitely it can be more than that.
Yeah, because
but in either case, they're still working group documents. So.
Okay, because I do have strong concerns about what they've done in the recent versions.
Okay.
Yeah. So given that they are working group documents, I think working group has a say in how the document is going to be shaped.
Yeah, because I appreciate your clarification, because again, in the standards, it's quite clear in my mind that their editors in the working group is working with the document, but with informational experimental, it's.
Yeah. I don't know, for the experimental case, Martin, do you have any comment on that? Because I think that's probably more where the ambiguity is, isn't it? Yeah. So I guess the question is if VXLAN GPE, for example, is published as experimental or goes forward as an experimental document, how much say does the working group have over the technical details of the draft? Because, of course, it's documenting an implementation.
Or at least it might be interpreted as documenting particular implementation. Again, and that's my interpretation of experimental, that it reflective of, in some cases we have at IETF where their implementation or de facto standard being put on the informational track. But experimental is more of really reflective of some experience of particular implementation. So basically that, we cannot really say, oh, you should have implemented differently, because the response, I would imagine, would be, no, but did it this way. You might disagree, but.
Well, at this point, it's informational, so maybe we can leave it that way and avoid the potential issues.
Well, my understanding is that if we don't have anybody from this group of working with the VXLAN GPE document, I think that needs to be discussed with them, what they would like to do.
I think we kind of need to have a consensus of the working group as well as to which way forward they want to go with this. If it's just simply you can argue probably that it could be experimental because we have one standards track document, so why are we arguing over or debating the technical details of another encapsulation? Why don't we just document what's been implemented for the other encapsulations? It seems perhaps a little contradictory to have one informational, this is my personal view, it seems slightly contradictory to have an informational document describing an encapsulation and a standards track document describing an encapsulation. But perhaps an experimental description might be more appropriate.
I think, in my view, the main problem with experimental is that you need to revisit it within 2 or 3 or whatever years afterwards, and if it's informational, you don't necessarily need to revisit it.
Okay. Okay. So the security requirements draft, that's on the agenda. That's next up on the agenda. I just want to have a note about, there's a draft that was originally discussed in the BFD working group for BFD over Genève. And it doesn't really propose any changes to BFD, I think. It's more about how you encapsulate it in Genève. And there was some discussion between the BFD and the NVO3 chairs about where this document should be progressed. And the feeling amongst the chairs was it should go forward in NVO3.
Yes, and we followed on your suggestion, and we resubmitted it with the individual draft NVO3.
Okay, yeah. So we will...
we are not presenting it this time, so...
Okay. I think what we'd like to see is some review of that draft, and we would like to go forward, or we think we should go forward with a working group adoption poll if there's sufficient interest in the working group. Okay, so can I get a show of hands? Has anyone read this document or this draft? Okay, 1, 2, 3, 4, 6. We definitely need a little bit more people reading it. Maybe Greg, if you can send something to the list asking for a review of it.
Yes, actually, as a call for, we want to ask you, first, let's discuss their encapsulation draft. So then we'll take this feedback from their NVO encapsulation discussion, use it in our BFD's document, and then we'll do a discussion of the BFD document.
Okay. Okay, so that's the working group status. Daniel.
Thank you. Hi. So I'm going to present a little bit the security around Geneva. So it's not especially focused on the requirements draft, but it's how we envision, Geneva security, the problem we have with the currently defined Geneva, and how we would like that to be moved forward. So, yeah, Geneva without transit device is really a end-to-end protocol, so we can use end-to-end security. So if you're willing to use IPsec or DTLS, works perfectly fine. When you have transit device, things change completely, depending on what you want to disclose to the transit device and what you don't want to disclose. But it is a fact that using end-to-end security protocol, you will always result in I'm hiding everything to the transit device, or I'm disclosing everything to the full world. And so there is a balance we need to find out with that. So that's what I can illustrate with this payload. So if you have both NVE are interpreting all the options. So you have the packet that is transmitted from one NVE to the other one. If you secure that with DTLS, the same with IPsec, a layer below. But if in that case, TLS will provide integrity and confidentiality protection for that Geneva packet from one NVE to the other one. So in this case, we assume that both NVE are processing all options and all the header and the payload and so on. And the purpose of TLS and DTLS is really to prevent that someone in the middle can intercept, read, or do whatever it's doing with that Geneva packet. So the contradiction is that when you're introducing a transit device, you're sort of defying the purpose of the security. So, as I mentioned earlier, you have two choices. Either you disclosed everything, so no protection at all, or you provide, you bypass the transit device. So suppose we're in a situation where NVE is providing option A, B, and C, and the other hand, NVE is only processing option A, but the transit device is supposed to process option B and C. So if without any protection, while the packet is sent through the transit device has a full access to everything in the Geneva packet, is processing option B and C, and you move that to NVE, that is processing option A. If you use DTLS, well, the thing is that the transit device can process the expected options, B, C, D. So only option A will be processed. In that example, the transit device is completely bypassed. So you either have this way, disclosing everything. So the transit device here might be the legitimate one. You may have another one that is not legitimate, but they have the same access to the same data. If you use DTLS, well, all the transit devices have been removed. So the current Geneva specification specifies that transit device can only read. And I think everyone agrees with that. It's okay, it's fine. But if you disclose everything and you don't provide any mechanisms, we don't have Geneva police. So if the device, you have no way to enforce this only read. So it's only that you trust that the transit device are behaving in a good manner. So we need, I mean, the purpose of the security here is really to, if we have only read, it doesn't mean it can't cause harm. We really have to provide some mechanisms that enforce that the transit device may access to some information, but can't do anything else than reading that information. And then we must also be able to limit the information the transit device is having access to. I mean, that you want the transit device to read an option, you may not want him to read the full packet or being able to monitor whatever traffic is being provided from one NVE to the other one. And so that's why you also need some sort of encryption. So with transit device, if you would like that, so transit device, so two things I mentioned, enforcing the read-only the data and restricting the data being accessed by that transit device. So on this graph, what I'm trying to show is that if you want to disclose some options to the transit device, then you can't use DTLS. So one way to do, and I'm happy to have other ways, but can I move and oh, there is a pointer.
Yeah.
I guess. Okay. So one way to do is that, okay, we need to disclose the option and maybe the Genève fixed header, so that, I mean, where you have the network identifier, because that might be used for routing purpose. So, okay, so this should be disclosed because those are going to be used by a transit device. But those, we don't need to disclose them because they are not useful for the transit device. And actually, we don't want this transit device to have access to this data. So one way to do is to provide a security option that says everything after is going to be encrypted. And that's going to be negotiated with this one. So this layer is encrypted. The transit device can't read this, but it can't read what it's supposed to read. And then, because telling the transit device, hey, you're only allowed to read. I mean, if he writes, or change the data, you have to be able to check that he's only going to read that data. So you need a kind of security authentication. So I put the A security option that says, okay, these are the data I'm disclosing to that transit device. And that's going to be authenticated. So in case you change that, this one will be able to check, hey, some option has been changed. It's not the packet that this NVE has been issuing. So basically, the communication is still between this NVE, and with such mechanisms, you can disclose some information to that transit device. I mean, do we have any question on why we do that and why DTLS or regular end-to-end security protocol doesn't work here? I'm happy to take any question.
So are you, sorry, Sami Boutros from VMware again, but are you saying we'll encrypt one option?
So, no. Oh, okay. So
we'll encrypt some of the options, I mean?
So here I'm saying it's like a marker. It's a proposed solution. So that can be
because
discussed.
I don't think that will work, right? Because the option length has to be known to the header, right? So you cannot encrypt some and leave some, right? I think what we discussed is that we'll only do authentication, right?
So this option basically will say from here it's going to be encrypted. And you can have.
You mean the whole packet will be an option? Will be option, but I as well won't work because we have a maximum length of 255.
Okay. So but the idea is to provide some means to say from that.
I think encrypting one option may not be
No.
possible.
Okay.
Daniel,
Some
sorry,
options,
can you use the
maybe.
mic? Daniel,
So, okay.
can you
Okay.
just pick it off the stand?
So, what you're saying is that, okay, options get, the length is specific, so we can't encrypt everything.
If we want to have something going clear, then we cannot encrypt the options, right? We cannot encrypt any option, period, right? Yeah.
There are, in this case, what I'm suggesting is that this option is going to be encrypted.
Correct, which is not possible. We can discuss it offline,
Okay.
but it's not possible. I think we discussed is being able to authenticate. And we can, I think we are saying we are allowed to read the option. It will be good, in my opinion, right, to change some of the option, not add option, but change it, which means that you can authenticate some of the option, not all options. So you can pick what you want to authenticate to allow the midpoint to change some of the options if they want to.
So what you would like is that some
just authentication for the option, if you are sending them in clear. And if you want to allow some of the option to change, then the authentication or the hash should not include the option.
Oh, yeah. But so what you're saying is that a transit device may change an option.
Correct. May update it, right? May
Okay.
change it,
So
update
that's a different requirement.
correct. I think we probably missed this one, so may want to consider this one for some application. But in terms of encrypting one option only, I don't think it's possible.
So it's feasible. It might not be a good idea.
I'm not sure if it's feasible.
Okay, so that we can discuss. But
sure.
it may make no sense to encrypt one option. That's the kind of things we'd like to know on how to design. The security requirements to know exactly what we would like to achieve, because we can end up in something very complex, which is what the requirements we have now are pretty complex because we're kind of opening all the different possibilities. Mm-hmm. So we might say...
it's only encrypt. I think, in my opinion, encrypt only the payload or the whole thing.
Okay. It's
so payload or whole thing. Options, we authenticate the whole thing or portion. That's it.
So what you're saying is that either we encrypt from here to here.
Encrypt the whole thing.
Okay, that
exactly.
could be DTLS.
Actually, you encrypt even the UDP, right? So IPsec.
Yeah. IPsec, we encrypt everything, or
the payload.
Only the payload.
Correct.
Okay.
That's my opinion. It's a private opinion as well. Right?
Okay, so which means all options will be either
encrypted
or not.
Correct. And the option can be authenticated.
Yeah.
All of them, or portion can be authenticated.
Okay. So that's a good point. I'm fine.
So we'll discuss more offline.
Yeah, we can discuss that.
It's Rango next in the queue.
Okay. Yes, are you able to hear me?
Yeah, can hear you.
Yes, okay, good. So first of all, I would like to state that architecturally what we envisioned is NV is an end-to-end protocol. I think we explained this multiple times during the, in the mailing list as well as part of the review. It's an end-to-end protocol. And so the transit devices are nothing but forwarding elements that are already available in the underlay network. It could be routers or switches and so on. So if if there is an end-to-end encryption is implied, which means that these forwarding elements will not be able to see the options, header, anything, that's perfectly fine. And we have already described saying that if such is the case, these elements, which are called as transit devices, will have to forward it like any other IP packet. That's it, right? So that's very clear. And these, forwarding devices or transit devices interpreting these options is not an absolute requirement for the functioning of the end-to-end protocol. So we did not, envision saying that, okay, let's just show part of this option to this particular transit device, and exchange keys between the transit device and the endpoint. That was not the intent at all, and that's very clear if you read the draft. I mean, there are many different protocols. Like example, if you take an RFC 8086, which is GRE over UDP, same thing. Equivalent. GRE key is an equivalent to an option here. There is no requirement that you go and just selectively encrypt or decrypt or send it in the clear, just the GRE key, so that some intermediate forwarding node needs to look at it. No, that's not the intent, right? Same here. I mean, Geneve is no different than any other UDP encapsulation protocol. So this whole argument, or talking about saying that, okay, let's go and show this partially encrypt some parts of the options. That's not supported in the architecture, and that's not what we really wanted to go in this direction.
Greg?
Yeah. Greg Muriski. Actually, I think that in addition to looking at the payload, we need to look at how this security framework will be impacting active OEM. Okay, because if we want to do trace route their tunnel that we're using, so to determine where in underlay we're traversing the network. So we need to transcending and how it will work if we're doing encryption, or are we saying that OEM would not be encrypted?
Okay.
And security would not apply to active OEM. So
okay.
Again, it's just we're not discussing it, don't have to discuss it now, and just something to think about it and look at how it may work.
Okay, so just one thing. When you say OEM, OEM is in the Geneva option?
No.
And that one should be, oh no, it's a bit in the header, is it?
Okay, the bit in the header now refers to as a control packet. We'll be discussing OEM encapsulation later today in the session. What I'm just saying is that active OEM is a specially constructed packet that injected. But what's important and critical is that active OEM follows the same path and receives the same treatment as a data flow packet. So basically, they're fade sharing. So with encrypting the data packets and, for example, possibly speculating not encrypting test packets will still enable us to do fade sharing or not. So
okay, so
that's something to think about. It again, don't need to answer now.
No. But I just want to understand. So this means the way I see that. So is that OEM is implemented through maybe an option and some fields in the fixed header?
No, OEM implemented for the payload.
Oh, within the payload.
Yes.
Okay, and so what you would like is that some payload would be non-encrypted.
Well, again, I envision that there is a need to traverse the underlay tunnel, and for that, the payload needs to be visible to transit node.
Okay, that's I mean, we have to check that how to make it, but it's interesting.
No, again, one possible scenario is that we'll say, okay, their active OEM for that purpose should not be encrypted, but the question then is that would that still preserve or let us preserve fade sharing with the data flow?
So, Sam Aldrin, Google. I just want to add one thing. If you're sending the packet, OEM packet, and or just the data plane itself is encrypted, right? From end to end, it doesn't mean anything because you cannot peek into the payload irrespectively whether you're a transit device or not. So that's how it should, because it should behave just like any other data packet. I mean, otherwise you are pretty much breaking the security whatever you have set up for the data plane. So I have a couple of high-level questions. The first one is, I know this was kind of discussed, but I just want to bring to the notice of working group. So we had this as Geneva security requirements.
Yeah.
Right? Why not NVO3? Because this is nothing to do with specifically Geneva. This should be for the virtual networks because we are driving the virtual networks.
Yeah. So I would say, does NVO3 got options defined?
As part of the data plane NCAP, that is part of that, the NCAP protocol.
Okay.
But
so one reason is that there is an NVO3 requirement document, and but this draft has not been continued. So we started at Geneva because one of the main difference between the security requirements provide for NVO3 did not consider the transit device.
Sure, but that goes to the meta question of like, what is transit device in the architecture? So that should be addressed from the architecture perspective, but not the security should define, or neither should NCAP define what transit is. That should be part of the architecture.
Oh, yeah, definitely. Because I mean, we are a little bit stuck because we don't understand what those transit devices do. And I think currently the situation we are is that we said, okay, so these devices have not been defined properly. So, well, they can have a single option they can read. They can have a single option dedicated for that device. They can encrypt. And probably we are providing too many use cases that are not intended to be used.
Sure, I understand, but that goes to the solution aspect, not the requirement aspect.
Okay, so the solution? Or
yeah. So from the requirement perspective, right?
Yeah.
If there is a definition for what transit device is, then the requirement should address
NVO3,
right?
Yeah.
That's pretty much it. If you're considering this as end-to-end protocol and you're going to define the protocol for end-to-end, then the security should address the end-to-end part of that. And for the transit, then we need to, I think Matthew can talk about that, what the transit, how we are planning to do that, but we shouldn't be defining what transit means as part of the security.
So,
okay.
Yeah, so I think the thing was when transit devices were originally envisaged, perhaps some people were saying they were more than just a router. I mean, they could be a firewall, for example, or there could be some other box that does some deep packet inspection or something on the NVO3 frame. So, and the problem is that was never discussed or never described as part of the NVO3 architecture, any of that functionality. And so the only definition that we really have of a transit device is in the Geneva encapsulation draft, which is a little bit of a, may not be a complete definition.
I think from what I understood from what Ilan was saying, if the transit device will be only a router or a firewall, exactly as you said, Matthew, right? Then it shouldn't be inspecting any option. Then the transit device here is simply a router, should not be looking at option. It's only the NVE who will look, right? So NVE can look, and now when we are talking about option between NVEs, should we encrypt them? Should we only authenticate them? And that's about it. So if an NVE will, if a device will inspect the options, then he's an NVE.
Yeah.
And I think we can go with that definition too. That should be fine. That there is no transit device that inspect option. Of course, transit device exists, but only as router or as firewalls that forwards IP packet and cannot look beyond the IP packet. Shouldn't even
well, the problem with that statement should not look beyond. We know today that routers do, because that's how they do ECMP.
Yeah, but router, if they do hashing on 5 tuples or even 7 tuples, they are looking at UDP or the transport layer 4. They don't look beyond layer 4, right? So the router, even the firewall, right? If you are talking about layer 4 firewall, they look only at UDP ports or TCP ports, so they look at layer 4. So yes, sure, you can look at layer 4 if it exists. If the NV decide to expose the UDP header and the Geneve header and not encrypted, then the router can look at it. Okay. And maybe this should be the definition, if everybody is okay with that, is that transit device really has no role in the in NVO3 architecture altogether, and in Geneve as well. They only exist because there are routers that can switch back.
Yeah. Okay.
Well, in practice, this exists, right? The devices, ECMP routers, for example, right? They look inside the packet, right? They skip over possibly the options and look inside the payload, and then might still employ ECMP policies, right? So that's
one second. You want the router here to look inside the payload after the option and do something with it?
It could. That's what I'm saying. Like that, we can't preclude that. If the packet is in the clear, no one can stop an intermediate device, right, in the underlying network to peer into or look into the information and then do what it wants to do. All we are saying is, if it is looking into it, then there are certain, restrictions. We are trying to, make the people aware that if they are looking into it, they're not supposed to do certain things. That's all been defined in the draft.
Okay, I see. So what you are saying, in other terms, is that the transit device can do whatever he needs to do to forward the packet, but really not alter any data on the packet.
That's exactly what we have defined in the draft. And if you're worried about a transit device tampering with the data, then there's a possibility for you to introduce an end-to-end authentication mechanism, so that data integrity mechanism.
And I think this is what we are saying, is that the options. What we are saying is that the whole packet is encrypted, then the transit device won't be able to look at any payload here because it's an encrypted packet.
Absolutely. Yes. If you're worried, yes.
Or if the packet goes in clear, you are right, the transit device can do whatever it can do with it, but without changing anything on the packet if security is in play with authentication, for example, right?
That's right.
So I think, yeah, those are the options we're discussing. I think we discussed an extra option in which you are saying the option header between NV, not a transit then, because I think with what you are saying here, who is handling options really, handling meaning processing, understanding what the option is about, and so on, is going to be NVs, not transit devices.
That's correct. That's what we have clearly explained in the draft, and what the security requirement draft is trying to go and interpret it in its own way, and trying to give some solutions like what Daniel is right now explaining, and that's not what is supported in the Geneva architecture. That's basically what I'm trying to say.
Okay, so from security aspect, we just need not to have any transit devices here. We'll just call them NV. So there is no from a security.
It will be there. It will be there whether we like it or not. These are underlay devices. These are devices in the underlay network.
We are not saying that the transit device will not be there, but what we are saying is not playing a role in security.
Right.
Meaning he's not authenticating, he's not encrypting, he's not decrypting. No,
it's not.
Not doing any of that. So the transit device exists as, from a security perspective, as a pass-through device.
I think just to solidify what you said earlier was, we do have similar technologies like VPN and all that stuff, right? And this is no different to that. So we shouldn't be redefining like the partial lookup or like the transit device, or there is no specification or precedence to set like partial option and those kind of things. That's what I'm trying to say.
Exactly.
Like, we shouldn't be coming up with some new requirement when other protocols which are already in existence do not define those things. And this is no different to that.
I agree. So I think the partial stuff that I mentioned, yes, I agree. It's not. If there are NVs now, then yes, they can change the option if they want to and re-authenticate and send again. So the whole option or the whole packet can be encrypted, or the whole packet can be authenticated, option and payload.
So having said that, the final thing, should we convert this to NVO3 requirements, NVO3 security requirements instead of Geneva requirements.
Yeah, so the NVO3 shouldn't worry about transit, right, in terms of security procedure. But as Geneva is defining it, the transit is a pass-through device for packet. Whatever it do with the packet, it's at its own discretion. But if security is in play, it should not change any option of the packet.
So in the Geneva, we won't have any transit device. Am I correct? In the specification.
Well, so
we
so
will,
it needs
not,
to be,
we will not have a transit device from the security procedure perspective, but the transit would exist to still forward the packets.
But the problem we have is that if the transit device is able to look at the options,
he can look at the option, but he's not allowed to alter or touch it.
So in going back to the parallel with VPN architectures, we do at least recognize I believe in going back to like the provider provision VPN architecture, the fact that what they call P routers exist, and they do describe them. So we're not defining. We got to recognize that they're there. So just saying they don't exist, but you can say they do not touch. You can say what they do not do to the, or they're not expected to do to the Geneva header.
Okay.
I think that's probably the way to do it. Like they can read it, but they don't terminate. As soon as you terminate it, that's an NVE.
Yes.
Correct.
Yes.
If you want to touch it, you are an NV.
If you want to change anything in it, you're an NVE, but you can read it. A transit device can read it and can do make some forwarding decision if it wants.
Yes, I can make forwarding decision based on it, but with no, if they want to, right? But with no touching of it, right, or altering it.
Yeah.
No.
If we can scope what it does to Geneva or doesn't do to Geneva.
I think from what I understand from what Philango is saying here is that Geneva apparently is describing this. So if that description is fine, then they already have a description for transit.
But there's nothing specific to Geneva about this. It's not special to Geneva. It's just written in the Geneva draft because it wasn't written down anywhere else.
So because Geneva was acknowledging that there will be devices between NVEs that will forward packet.
Because a lot of this discussion arose after the NVO3 architecture was done. So
correct. So maybe for the NVO3 architecture probably assumes that there will be transit device, but they will have no role. No role for terminating tunnel or starting tunnel.
I don't recall the discussion even coming up until we started talking about transcending trace through OEM.
I see. Okay. Yeah, but I think
because there's OEM implications to these things as well. So
definitely, but in terms of OEM as well, with trace route and so on, it can be treated like an IP packet, right? An IP UDP packet, a router. If the TTL expire, he will send the ICMP error back, right? So.
Well, that's for the underlay, but I mean, if you do something, but there's ways in which you
there
would
is a draft on transcending as well, right?
Yeah.
That I guess is. It's not refreshed. It was not refreshed recently, but
I think the objective of that was to trace a particular VNI.
I see. Okay.
Like where it went through in the underlay.
I assume here with what we are defining, if security is implied, then the transit cannot really change any option of the packet.
Yeah.
Right? So,
but that doesn't. That effectively pops it out and terminates it and replies somehow.
So even if you want to do a trace route for VNIs, then it should be okay.
Yeah.
But a device that has a different behavior, if it's secure or non-secure, is bringing a contradiction into the architecture. Because it means if you want to secure that deployment, you have to balance.
But the idea here is that the ingress point and the egress point are the only nodes who are allowed to touch, terminate, and do anything with the packet, right?
Yeah.
So if you are touching, you are an NVE. You are terminating a tunnel, you are an NVE. If you want to do trace route between those two NVE via transit routers, right, it's fine too, right? Because they are not going to be touching anything on the packet. They will simply be sending errors back or something, right? So some indication back to the ingress point that, yes, I am on the way.
Yeah, but the thing is that if you have a deployment that is going through a transit device and you rely on the fact that he's inspecting the packet, you won't be able to secure that.
That's fine, but that's the architecture, or that's a deployment scenario where like we do have like VCCV deployments, we have VPN deployments, right? If you don't secure end to end, then you are defining your network design to make sure that others can actually inspect the packet. But if you really want to do that, you secure the whole payload, including whatever
exactly
you
require. Exactly, all transit won't appear. It will appear, the NVEs will be like one hub away.
So in other words, there is no requirement to say that there is a way for the transit device to look into that, as long as the payload, the network or the encapsulation allows it. There is no requirement that it should or shouldn't do certain things, selective things. If the end-to-end is encrypted, period, you cannot look into that.
Okay.
If it is not restricted or not encrypted, then transit device can look into that.
But if
they touch it, then they break security.
But if you have a deployment where that is relying on those transit device, and then you have been asked to say, well, can you secure this NVE to NVE communications?
You still can secure it because you are either encrypting between the NVE, so the transit is a pass-through, doesn't know what's inside the packet, or you can authenticate. And in that case, yes, he can look because the data is clear, but he cannot do much as well, right? He's only looking at what you sent in clear.
But that's a huge impact. I mean, the deployment cannot be, the deployment of security is going to be deeply impacted by those transit devices because depending on what you want.
The deployment of security, I think, as Sam said, is at your discretion. You want to show stuff in clear or not. If you don't want to show stuff in clear, then the transit is simply forwarding an IP packet.
But once you choose, you can't go back. It's really hard.
That's fine.
And that's fine.
That's how even the VPN transit is right now. I'm sorry.
Okay. So I think we should take this to this because we've got 3 more drafts in the session. Okay. Thanks, Daniel.
Thank you.
Thank you.
Henry.
So, hello everyone. So here we arrive at the 6th version of this draft. And you may notice that we have new members on our design team. Especially we have Ran, who is author of another young draft, which is dedicated for Genève and the VXLAN GPE. So the design methodology of these 2 drafts is aligned, and in the future, the 2 drafts will be well coordinated. So firstly, I would like to recall the motivation of this draft. So in IETF, in terms of network virtualization overlay, the data plane and the control plane have been covered, and there are several related works on it. And clearly, the YAML model is still a gap, so to be covered. And why we start with a base NVO3 YAML? Because there are several encapsulations and VPN technologies. And if we run directly into individual encapsulations, we'll run into repetitive works and a non-consistent approach. So it is better to start with a common and reusable YAML in the first place. And it can be used as a start point for individual encapsulation to people can actually augment this base YAML any time when necessary to define the YAML model for an individual encapsulation. And in this base NVO3 YAML model, we have used the reference such as the NVO3 RFCs, for example, the framework architecture, and we have used the related RFCs and works in progress in IETF. So there is a relatively significant change in the current version. And in the previous version, the NVE is defined as a container. And inside this container, we defined the VR instances. But now we define the NVE as an interface. Actually, Ignace has a comment during the last IETF, and we think it is a good idea, so we adopt it. And now the NVE is defined as an interface by augmenting the IETF interface YAM. And in the base NVO3 YAM module, we have indicated which NVE interface that the VNI instance is mounted to. So basically, the relationship between the VNI and the NVE is still the same, but here we use a different logic. And here you have the source VTF IP, which is the address of the Anycast gateway if it is enabled here. And if it is enabled, we should have a bypass VTF IP to identify uniquely the NVE inside this Anycast gateway. And this slide gives you an impression about how the NVO3 base YAM is mapped to the architecture. And inside the base NVO3 YAM module, we define the VNI instances, and here the VNI ID is configured and used as a key of the VNI instance. And here, as you can see, we have the source NVE indicating that which NVE interface is mounted to. And we have also a BGP control plane enabler to indicate if the NVEs are configured dynamically via the BGP control plane, or it is configured statistically. And if it is the later case, the static peer NVE are defined here. So we also have the multicast group defined per VNI basis, and for different VNI, we can have different multicast service nodes. And another change is that the mapping between the L2 VPN or L3 VPN to the VNI instance, it is now defined by augmenting the IETF L2 VPN or L3 VPN module. And in the previous version, the mapping relationship between the VNI and L2 or L3 VPN, it is defined in the NVE container. So next step, we open to your comments. And if you think that we are moving in the right direction, or the idea to define the base YAM module is the right direction, please consider adopt this draft as a working group document. So any comments?
Okay, can I get a show of hands for, please raise your hand if you've read this document. That's quite a good number of people. Okay, we'll take the list. Thank you.
So good afternoon. My name is Sami Boutros from VMware. I'm presenting the MacMove draft. So yeah, we presented this draft, I think, last year. So the idea here is that the use case we are talking about here is a dual home device, right? Between, let's say, a couple of NVE, and we are doing data plane MacLearning. So we're talking here about data plane MacLearning with a dual home device. So now, you know, that dual home device, if there will be a failure, so here the dual home device as well is not, the access here is not VLAN. It is a Genève tunnel between what we call layer 2 service and the NVEs. So you have a Genève tunnel between the NVEs, of course, and between the layer 2 device and the NVE. So now those NVEs, of course, they can be talking control planes, they can be talking EVPN, talking whatever control plane to distribute MACs or MAC IP bindings. And now if the primary pass for that dual home device goes down, then there is no way for the dual home device to know that he is going now to be getting traffic from the backup NV. So for it to know that, we are proposing the extension. So again, in simple term, a device, the device could be a hypervisor, for example, dual home to two NVs, two leaves, two TORs, and he is setting up VXLAN tunnel to those NVs. Setting up Genève tunnels to those NVs. And now the NVs, there is a failover between the primary to the backup NV. And the backup NV has to give an indication to the device saying, okay, hey, a switchover happened. So this is it, right? So are saying we can have a new Genève option TLV. This option TLV we can send on the Genève packet, right, to send the failover notification when the backup or the standby NVE becomes active, right? And the document described a very simple protocol following what we did as well for MPLS TP. For MPLS TP, we had a MAC withdrawal draft. And the document here follows the same thing, follow exactly the same protocol. It's a very simple data pass protocol to increase, of course, the reliability and make sure that message will arrive, for example, to the device saying that the backup is sending, saying, I am now the active NVE, and all the MAC that you learned from the primary NVE are now reachable by me. So I think in short, that's it. Any comments?
Jorge Rabadan, Nokia. Can you go back to the diagram, please? So the target scenario is basically you are building this hierarchical Genève. So
it's not hierarchical. It's not hierarchical.
You mentioned from the layer 2 device.
It's Genève tunnels. Genève tunnels. Access Genève.
Okay, and the other side you have.
The other side, can be anything. Can be mesh, of course. Could be mesh of tunnels. Could be MPLS. Could be anything.
So it could be EVPN based.
Yeah. Of course. This is what I mentioned as well. It may not be very clear here, but the other side could be MPLS based. I think what's being said here, if you imagine the whole network is data plane learning, right? A data plane MAC learning, then the other side can use the similar mechanism.
But if you use a data plane, so the messages that you are defining, basically what they say is, okay, there was a move.
Correct.
From an old VTEP to a new VTEP.
Correct, that's it.
But you do not define a list of MAC addresses.
No. Only all what you learned from the old VTEP are reachable now via me. It's not, the MPLS TP MAC withdrawal stuff was defining a list of MAC. No, that's not doing that.
Yeah, I know. So what here, what that means is that basically you only have one layer 2 device, right? Because, so NVE2 is the one sending this MAC move message.
Correct.
Right?
Correct.
And
sorry,
so
what do you mean?
Telling the remote NVEs, hey, all the
it's
the
not
Macs.
telling the remote NVE, it's telling him.
Oh.
Okay, I'm sorry. Okay, I have to update. I have to update the slide. Okay.
No, the use case is super confusing for me.
No. Okay. I think this was the old slide. So the MAC move is going to happen. Going back to the device.
So you're telling the layer 2 device that all the
that I
MACs
switched
moved.
Correct. I think the arrows. So this, of course, the others are still good. Because he's going to tell the others too, right?
But
if you are EVPN, you switch over.
Yeah.
You're going to tell the others.
But your backmost signaling arrow is going the wrong way, isn't it? On that, on towards the it should be towards the layer 2.
Okay,
service.
so yeah, I'm trying to figure out the slide was done a year ago, but okay, so even in EVPN, if you do a switch over, you have to tell the others, right?
You have to tell others. Well, first of all, you advertise MAC addresses from a given Ethernet segment, so you tell others flash MAC addresses from this Ethernet segment, not from a VTAP to a different VTAP, right?
Yeah, I'm saying on the access, you will move from VTAP to VTAP if you are doing MAC learning on the access.
Okay, it's very confusing for me. Sorry.
We can discuss it offline if it's not clear. I'm gonna clarify more the slide as well, so I will update the draft too.
Okay, thank you.
No problem.
Justin, sure. So I agree on the comment. It's confusing. I read it a number of times.
Okay.
And the probably name is confusing as well because it's not really that MAC has moved. It's that the interface became unavailable. So you're pretty much signaling. You've got some relationship between NV1 and NV2 from the service perspective. So if you just
NV1 and 2 are providing redundancy to
exactly.
the device.
So you've got the relationship. So you just need to tell the layer 2 service in this case that switch is down. So it's not really MAC move. It's everything move, right? You just move from one interface to another. You flush.
Yeah, we are not flushing.
No, so
it's
you.
not an interface. This is a unique tunnel. This is a unique tunnel.
I understand, but the service you represent here is going to rewrite the destination for all MAC addresses has learned from NV1 to NV2, right? So it's not.
The MAC address that you learned by NV1 now is available by NV2. This is what NV2 tell the device. That's it.
Yeah, so it's just a bit confusing when
yeah, sure. I'll update the draft. The original version of the draft may be confusing, but the idea, what you need to read was here, is that those two NVE are providing redundancy to the device. Now, when that guy failed, they have unique tunnel.
Sure. When you explain it here, it's clear. When you read it, it's not
clear. Yeah, but I will update the draft to make it to match the explanation I'm saying.
Usually, actually, I think we did more or less the similar thing in Trill before. So there are some.
You did? Sorry.
Trill, TRIL. There is another protocol, yeah, but it's already concluded. The work.
It's called Trill. Trill working.
Oh, Trill.
So, but I kind of think there are some ideas we could borrow. There are some tricky points here. For example, for the NVE1 and 2, you say the primary and standby, are they supposed to use some like Anycast IP address for both of them, or they are using different IP addresses there too?
Of course, if you want to use Anycast, that's another approach. I'm talking here about a non-Anycast approach.
Oh yeah, then for the MAC move signal, if you think it's like a gratuitous ARP. So it looks like to me, it's possibly we just directly flush out the ARP.
I think we are making the assumption that NV1 and NV2 are on the same layer 2 segment, and we can use to the device, gratuitous ARP or when the Anycast switch from NV1 to NV2, then we really don't need to do anything at the device.
So you, just now you said it's not the black arrows. They are not multicast, right? It's a multiple single, multiple unicast. Okay, so for the ME2 to 1, there is no special tunnel because it looks.
There is.
It's a special tunnel, different from all the others.
No, not special. It's part of the mesh. The green are two tunnels.
Okay. Okay, I guess there are some.
I think the slide was talking about an all Genève data plane MAC learning stuff, right? But what we will change, just to make sure it's clear and very easy to understand, is that we won't care about the core of the network, that cloud thing. The core of the network won't care about it. Only the access is what we'll focus on, right? And it's similar to sudoer. If you are familiar with sudoer, we switch from primary to backup, and we send, in sudoer, we used to send what we call sudoer status. So this is very similar to sudoer status, but we are sending it in band in Geneva.
I understand the motivation. Actually, I think this somehow should be required. But the mechanism, I guess, may.
I will update the mechanism, and please send comments. I'll update the mechanism. Wait for the refresh, and the mechanism will be very clear now. Go ahead.
Alberto Rodriguez, Cisco. Sorry, I'm still trying to understand, and sorry if I ask an obvious question, but so the MAC move signal goes within the Geneva encapsulation of the data plane.
Correct.
Okay, so you need data plane traffic to trigger the updates, I guess.
No. It's a special message. You send a Geneva packet with the option, with no data, no payload. You don't need traffic to send it.
So it's a Geneva, let's say, control plane signal.
Sure, if you want to call it this way.
Okay, I'm trying to figure out in my head what it was. Okay, that's it.
Thank you. Any more comments? Okay, thanks, folks.
Okay, thanks, Sammy. Greg.
Okay, so the question is, and we had a very good discussion in Prague, is how we encapsulate active OEM in Geneva. So what is active OEM? Active OEM uses specially constructed packets to monitor, troubleshoot, localize defects, and must be not leaked out of Geneva domain, and multiple active OEM are required to support full management performance monitoring, fault management. Active OEM protocols must be clearly identifiable in Geneva. So we have 4 options for your consideration and discussion: IP UDP encapsulation, direct identifier, MPLS generic associated channel header, and Geneva associated header. Okay, let's start with IP. Well understood. We have Geneva header. Obviously, there is transport encapsulation above Geneva. And after Geneva, the next protocol points, the protocol type points to IPv4 or IPv6. Since we're using either types, these are readily available. And after the Geneva header, we have inner IP or v6 header, and the destination IP address, it's either, so it's one of the Martian addresses, and the multiplexing is based on destination UDP port. Usually active OEM uses UDP and already assigned UDP port numbers and maintained in IANA registry. Okay, so that's pretty simple. It's well understood. It's a well-known method for example, MPLS LSP tunnels. But the problem is that it adds up on IP UDP overhead. And as was mentioned in a discussion in Prague, it potentially creates a possibility of generating false negative if something wrong with the IP UDP encapsulation, because it distances their OEM packet from the Geneva header. Direct encapsulation. So the protocol type is active OEM type for each of protocols. And then following their Geneva header, you have your control message. No overhead, but then because there will likely will be a multiplicity of protocols, for example, echo request reply, BFD, performance measurement protocol. There could be some coordination for protection switchover or anything else. That each of protocols will require its own type assignment. MPLS generic associated channel, so it will use MPLS protocol type, and then after their Geneve header will follow GAL, generic associated label, and it will be marked as bottom of the stack. So it will be only one label, and that will be followed by a generic associated channel header, which is very similar with the well-known pseudowire associated channel header. And we use the channel types that already maintain in IANA registry pseudowire SCH gash types, and followed by the body of their active protocol message. So positive, we reuse pseudowire VCCV method or with GAL, and we don't need to define new protocols because pretty much everything is already defined for pseudowire VCCV.
So just a question, why are you using a GAL here rather than the OBIT?
Because the OBIT is not defined. OBIT is not clear where the OEM is. Is it OEM in extensions or OEM in a payload? Here is a clear protocol type, and then we go in the protocol. In the protocol, just then we go, it's MPLS. We look past the header. It tells MPLS. We go, we look, this is GAL. We know that GAL means it's a ACH or gash, and then we go there. So we don't need OBIT here. Everything is straightforward without
well, no, I mean, the question is, should the OBIT be better defined?
I
mean, it seems to me that you've got two potential.
Yes, I was pointing.
Exception mechanism.
Yes, I was pointing that all the way for discussion of Geneve encapsulation, and I was of opinion that we don't need OBIT. Or at least we don't need OBIT for identifying OEM case, at least OEM active OEM, we don't need OBIT. If somebody wants to use OBIT to identify the presence of OEM information in extensions, of course. But for active OEM, I don't see the reason. We have protocol type, that's sufficient.
Prakash Jain from Cisco. How is different than the existing that NVO3 OM draft? There was an earlier draft also for this, right?
I don't recall the NVO draft OEM.
I don't know, it's a framework or it was a draft, but it was a similar OM channel was used with the 8902 ether type.
Again, if you can send me the link or make certain, because again, similar information is in Geneve BFD draft, yes, because two co-authors discussed it and put it there, but then we decided to extract it and first discuss this. But I don't know, frankly, draft. I'm not familiar with the draft with your. Yeah, just if you can find the draft and send it to the list. Thank you. Okay, and the last is Geneve associated channel. Then we need to define OEM protocol type, so it's Ethernet, but we can reuse existing Ether type for OEM. It's already there. And then we don't need a GAL. We can reuse format similar to pseudowire VCCV, reuse the channel types, and active OEM. So there is minimum overhead of just ACH for octets, and actually we don't need to create new registry. We already have all types in.
So which code point which ether type are you using?
OEM.
I thought
there's
a generic OEM one. Is it?
Yeah.
Okay.
The same that 1731 is using.
But it's not 1731. That's
No. Right, but we're using the same ether type. Yes. Okay.
Yeah.
Sure.
Yeah. Okay.
Okay. So that's what we're proposing, and we appreciate the discussion, your consideration, and what we would like to ask chairs is to put a time limit on the discussion. So basically, to put the terms of when we want to arrive to conclusion.
So what specifically is the question? Which of the encapsulations should
be taken? We need to select one encapsulation. We don't need multiple because that will be painful for everyone.
So on this, Frank Bruckner's quick one on, just for my understanding. So if the protocol type is OEM, that's the aforementioned 8902 ether type. That means the active OEM packet would be CFM, or what goes into this active OEM thingy there?
No, it doesn't have to be CFM. Why it has to be CFM?
Now I'm trying to understand what active protocol OEM type that is, and what you're assuming that goes into active OEM.
I assume it can go, for example, BFD control packet.
So say again?
BFD control packet, because it will be channel type. The channel type defines what is active OEM. Not protocol type defines what active OEM. The channel type defines what active OEM. The multiplexing is based on channel type.
Okay. And what would go into active OEM? What do you foresee going there?
Either type OEM. Why?
Give me an example.
What?
Give me an example of what active OEM packet would mean from your perspective there.
I already told it's BFD control packet, for example. Channel type. Have you looked at pseudowire VCCV?
Okay, well, I get it.
Okay. So I think my concern is overloading the
BFD stuff in.
Yeah, overloading the meaning of the protocol type OEM. If that really means effectively CFM.
Yeah, but we are reusing it.
Well, but it's not CFM here. It's ACH.
Yes, it's Ethernet ACH. Okay, then.
So do we need an ether type for ACH based OEM? Yeah.
Okay, if it's confusing, then we can get another ether type. But I think that one option for the Geneve, we can reuse it. Because if we can use, for example, IP over Ethernet as indication of IP payload, then why we cannot use Ethernet OEM as indication of Geneve OEM? I understand that we're not allocating new IP over Geneve ether type. Or are we? My understanding is where we're using IP over Ethernet, right? So is it confusing? No?
Tal Mizrahi. So are you suggesting to use channel type 8902?
No, the channel type it's what's in a IANA pseudowire ACH registry. So it's a BFD, it's all there. So, and that's a demultiplexing. What I'm suggesting is to use protocol type as Ethernet OEM.
Well, so I think my concern is here is of the extensibility in future if we do want to run raw CFM over this, then what do you use for the protocol type?
But why would we run CFM over Geneve? The CFM can be run over service, and then it will be encapsulated, and actually that will be transported as pure data, because if it's end-to-end Ethernet OEM, that for Geneve, it's a data.
Well, in theory, but there's use cases where CFM gets run out of all sorts of things. So I just a question of whether or not it's appropriate for the protocol type field to say CFM there rather than Geneve OEM or something.
But again, again, to run CFM, it will require so much additional configuration. So I really don't see the case, and why would we do it for layer 3? Because we understand that you need to configure maintenance domain name, maintenance domain association. So the complexity of running layer 2 OEM when we can run layer 3 OEM on this tunnel segment.
Correct, but the issue here is it's confusing to overload a well-recognized code point for the protocol type.
Okay, well, if that's
if you take a Wireshark snapshot of the packet, you might expect that if it says CFM in the protocol type, you're carrying directly CFM.
I need to double check what it's really interpretation of either type, but it's not really a sticking point. So if that's the problem, we can ask to allocate another either type.
Yeah.
So.
Just Prakash Francisco. So CFM can go over the tunnel or over any of the technology too, right? So it's not that exactly that layer 2 service level OEM.
Yeah, but the thing is that actually if CFM goes over tunnel, it goes as data. It doesn't go as CFM. Okay? So then in this encapsulation, it will be Ethernet. Genève will see CFM as Ethernet, not as CFM.
That's exactly my question earlier, was that there was a draft to use the CFM ether type for
can you be so kind and send the name of the draft and links to the draft, because otherwise I cannot answer you.
Yeah, sure, but my question here is that are you proposing here to use the 8902 as a protocol type?
That's one of the proposals, yes. But if a group thinks that it's confusing, we can look for allocation of new either type.
Just to, sorry, Ignace, one quick clarification on that. So how do you want a working group to respond? You have multiple proposals, right? So how exactly you would like working group to actually come back to you?
Well, I think that we need to start eliminating. So we need to start eliminating some options and saying, okay, this is not acceptable at all. And so probably we'll end up, what I would like is first, in the first phase of discussion, end up with 2 options. Okay, so let's first eliminate 2 options out of 4. And once we get two options, then we'll have more extended discussion.
So you're gonna take that action item to eliminate 2?
What I will do is I will send a note and I would expect people to vote, because I think that eliminating 2 options doesn't require a real argumented technical discussion. Okay, Martin of a different opinion or has a proposal.
No, simply to say, Martin, we don't vote.
Okay. Okay, no voting. Then any other format, because what I would like to do is I would like to have to make this decision way before meeting in Singapore.
So ideally, as a start, we need some discussion on this on the list, so we can get some consensus on the pros and cons of the different approaches.
Okay, then let's have a just discussion
Start with that.
Start a discussion, and then we'll try to measure the level of support, but I would probably do it in 2 rounds. So the first round is with the objective to get to 2 options, and then in the second round, just get 1 option.
Yeah, we'll have to see how it goes, because we don't have a very good record of coming to consensus on encapsulation options for anything in NVO3 on the list. So we may have to, as a second step, have to go for a design team approach.
Actually, then I would ask chairs to decide what the nuclear option will be, because then, well, you would say, if you don't come to consensus, the nuclear option is this.
I think the chairs would have to decide, would have to see what the consensus is in the working group, or get a design team to come up with a recommendation that we can then get consensus on in the working group.
Okay, well,
if there's not insufficient discussion on the list, I suspect
no, again,
the design team.
Okay.
Ignas Bogdanas, Data VAD. And I do have a comment, question, and a rant at the same time. What is the goal of this? What we are trying to achieve here? And especially from the actual usability perspective. Greg, you mentioned about CFM and the complexity of that. CFM is a technology stack which is rather well understood in the field. And basically the community uses that for layer 2 manageability purposes. That's rather well known. If we're trying to invent something similar but not the same, that probably would not resonate too well with the community. That's just additional complexity. Can we run CFM over this channel? And while we are happily talking about the fields, values, bits, and other things, what is the general problem that is being addressed here? What's a deliverable out of that? To provide 4 different encapsulations and channels to carry OEM, not necessarily knowing what are the problems, what that OEM is solving? Do we have the requirements, what is needed for running these types of networks? Do we have a view on the overall manageability of the stack? So basically, the NVO tunnel running on some form of underlay, how that what are the manageability problems there? And I don't expect an answer from you here. This is basically an open question, but do we have this understanding?
Well, we don't have it formulated in a document. Yes, that's the case. I would say that at IETF, we do have well-developed and long-time deployed and tested OEM stack. It's not that might be coherent. Like, again, CFM might not be the best example. I would then use 1731 because 1731 combines fault management and performance monitoring. But we do have a suite of active OEM tools that are functionally matched to 1731. So I would not say that we're inventing new OEM protocol. No, I know the relationship, but I'm saying the functionally CFM is much shorter than 1731.
Yeah.
No. So no other way.
I think, Ignas, you have a good point here, because if I think back to the OEM protocols that we defined for those channel types, or that are identified by those channel types you listed there, a number of them were originally developed in the context of an MPLS transport network, not a data center VPN. So there is a question here of which of those are actually applicable in this sort of operational environment.
Again, if we look from the field perspective, MPLS OEM is another technology stack which is rather well understood by the community. If we can take and reuse that, that would definitely be a benefit, instead of trying to reinvent something new, which basically does the same function but in a different way.
Right, but that's basically, if you look at this, again, MPLS OEM stack and IP OEM stack are practically identical, okay? Because it was not developed for MPLS, it was adapted from IP into MPLS, or at least created look-alike, for example, LSP ping. BFD works the same way as it works in IP network. It works over MPLS LSP tunnels.
I'm not arguing with that.
Okay, so again, what we are discussing here is what the best and simplest way to make available OEM toolset work over Geneva tunnel. The goal of this discussion is not to develop new OEM protocol, but how to make existing OEM tools to work over Geneva.
So I'm very happy by the first part of the answer. Please don't invent yet another OEM thing, because there are plenty. I think this is definitely for, I don't want to occupy the time, this is definitely for a broader discussion over the broader community. I kind of get the feeling that the group does not necessarily see the clear view of how this can be used. What are the actual requirements? Maybe that would be a good starting point to see what is available and how those things are being used. Basically, what are the problems in these types of deployments and how to address those?
I agree that actually the requirements for OEM functions, it's a good document to produce, but I don't see that this discussion of how we encapsulate active OEM and discussion of what we need to do in active OEM, I think they can go concurrently in parallel. They're not gating each other, because this is not what we do. This is how we do it. What we do is different. Okay, so discuss, decide, and then we were planning to do look at what extensions we need for echo request reply, because continuing on what Ignas said, I do believe that yes, this environment may require certain extensions to echo reply functionality, especially to probe their particular things. Okay, but so as I understand, just check my understanding, verify with you, that I will send the email starting the discussion. You'll be judging the consensus.
Yeah, I think in addition to this, I think Ignas made a very good point about the requirements here.
Mm-hmm.
Just thinking back to some of the, I mean, normally which tools you need to use in a given environment probably shouldn't dictate the encapsulation, but maybe here it might influence, say, the choice between UDP and ACH.
Okay.
Because there's a whole bunch of tools supported
actually,
by ACH that are not supported in the UDP environment.
I have to bring back history. Some time ago, we had overlay OEM design team. An overlay OEM design team came up with their requirements. And then we were told, and I was told that, oh, no, we don't need this document.
Mm-hmm.
So we have a document at least that we can start working with, because it lists requirements. I can bring it up. I can bring it into NVO group specifically. And then the working group can start looking and say, okay, yes, that's relevant. No, that's not relevant. And that's missing. So would that be a plan to play? Game plan?
I think this is going back and forth, right?
Yep.
We have had this effort within the routing area.
Yes.
To form the design team, and
design team worked. It produced number of documents, and among these documents was pretty generic, I will admit, list of requirements. We can start it from scratch, or we can start it from the existing document.
I don't have the context of that, but at least my understanding of the outcome was that there was no consensus on what is to be done.
Okay, then I will rest my case.
I think we need to take this to the list.
Okay.
All right. Thanks, Greg. And I think that's it. Thank you.